Welcome to True Projects. In this video, we are going to explain about a project titled Detection and Tracking the Meat Prawns Challenge. In recent years, there has been a significant surge in the interest surrounding the drones, also known as unmanned aerial vehicles, especially those equipped with the advanced camera system. These drones, enhanced with embedded technologies, have the remarkable ability to not only capture the data from the surroundings but also process it. This innovation has opened the door to the multitude of the novel applications including agriculture, aerial photography, shipping and delivery, security and surveillance, and search and rescue operations. This growing demand for the interpretation of visual data collected by drones has led to a close integration of computer vision and the drone technology. Addressing the key challenges such as object detection and tracking has become the paramount in the convergence. However, the progress is hindered by the limited size and the scope of available data set, attributed to the complexities of the data collection and the annotation. As a result, there remains an ongoing need to develop the assets and enhance the new vision algorithms tailored to distant visual data captured by drones while also continuing to tackle the challenges the comprehensive algorithm evolution. And the project aims to advance the progress of object detection and tracking the algorithms trialed for the drone through the challenge workshops and the provision of an extensive data set named VisDrone. Derived from the drone captured visual, this comprehensive data set comprises of the four different distinct tracks: the image object detection, video object detection, single object tracking, and multi-object tracking. Additionally, this project offers a comprehensive appraisal of existing object detection and tracking the dataset and the benchmark. It delves into the intricacy of curating the large-scale drone-centric dataset with meticulously crafted manual annotation. And these are the basic requirements that are needed to build this project. The software requirements are Python IDEL with version of 3.7, Anaconda 3.7, Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the packages. We need to import the necessary Python libraries, packages, and frameworks such as TensorFlow, PyTorch, OpenCV. And the next one is exploring the dataset. To analyze the VisDrone dataset, examine its structure, content, and annotation. This step aids in understanding the dataset characteristics and prepares for the subsequent processing. And the next one is image processing. Implement this image processing technique including resizing, normalization, and the enhancement to optimize the quality of image for the model input. And the next one is loading the pre-trained model. Loading the pre-trained object detection and tracking the models like YOLO V5, V6, FASTA RCNN, DRNN, RetinaNet, Cascaded RCNN, and Mask RCNN. And the next one is data augmentation. Apply the data augmentation method such as random swapping, flipping, and rotation to augment the dataset, enhance the model robustness, and the generalization. And the next one is processing the data based on the YOLO V5 model. YOLO V5 model is used to process the captured images leveraging its real-time object detection capability. And the next step is building the models. Various machine learning models are built, and the first one is YOLO V5. It's a real-time object detection model known for its speed and accuracy. It divides the input image into the grid and predicts the bounding boxes and the class probability directly. YOLO V5 is suitable for the drone due to its efficiency, making it possible to process the images in the real time. Its lightweight architecture allows for the fast deployment on the resource-constrained platform, which is beneficial for the onboard processing on drones. And the second one is YOLO V6. It would be the advancement of the variant of YOLO architecture building upon its strength while potentially offering the improved accuracy and the efficiency. And it is recommended for any updates related to this YOLO 6 to be officially known. And the next one is faster RCNN. It is a region-based object detection model that utilizes a region proposal network to suggest the potential object location in an image. It is known for its accuracy and robustness in detecting the object of varying sizes and the scales. In the context of drones, faster RCNN can provide the detailed object detection and tracking the result, making it suitable for the scenarios where the precise localization is essential. And the next one is DRNN RetinaNet. It's another single-stage object detection model that uses a focal close of address, the class imbalance issue, and the dense object detection. Adding the dynamic recurrent neural network component would imply the temporal aspect to object tracking, which assigns to the dynamic nature of drone captured imagery. This combination enhances the ability to track the object over the time, a crucial aspect when dealing with the moving subjects from the aerial perspective. And the next one is cascaded RCNN. It involves a series of detectors that refine the object detection process in the stages. This hierarchical approach improves the accuracy by focusing on the challenging cases, and in the cascaded RCNN is particularly useful in dealing with the complex scenes with varying level of visibility in drawn images. And the next one is Mark RCNN. It extends the object detection to instance segmentation by providing the pixel level mask for each detected object. This model is beneficial when fine-grained the object understanding is required, such as distinguishing between the object with intricate shape and those that are closely packed together. In a drone-related context, Mark RCNN can enhance the tracking precision by providing the detailed spatial information about the detected object. And the next one is user gives the input as of image or video. And here we set up a flash-based user interface to facilitate the user interaction. Users gives the input to this interface, initiating the detection and the tracking process. And the next step is the given input is pre-processed for prediction. Process the user provided image for the prediction by applying the similar pre-processing step as of mentioned. And the next one is the segmented each object and put the bounding box. Leverage the ensemble of models to segment the object within the input image and draw the bounding box around them, effectively identifying and localizing the objects of interest. And the last one is final outcome is displayed through frontend. Present the annotated image with the bounding box through a user-friendly frontend. This visual communicates the result of object detection and tracking to the user. And the execution of the project. To execute the project first, we need to open the code folder. And this is the code folder containing of various files within it, the sample folder containing of the images that will be used to test the performance of the model, and the static folder containing of the folders like CSS, images, fonts, JavaScript files within it, and the template folder containing of HTML documents. It typically include of home, index, results, sign in, sign up, and notebook pages within it. And the YOLO V5 and V6 contains the models, and the app is an py file which likely contain the information related to the front-end logic, and it includes the code written in Python that handle the server-side operation such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the notebook is an IPYNB file which contains the combination of code, graph, and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And the signup.db is a file appeared to be the database file used to store the user information. And for the execution of the project, first we need to copy this code folder path and then open the Anaconda prompt. Here we need to write a command cd space and paste this code folder path. By this, it will change the country directory to the code folder path, and then click on the enter button. Here we need to write a command that is python space app.py. By using this command, it will execute the Python script and perform the runtime check for any syntax errors or the logical issues. And then click on the enter button. After running this app.py file, the Flash framework will host the application locally at the default address like this. We need to copy this link and paste it on any of the web browser of our choice, and I prefer to use the Google Chrome. I'm pasting this link. and then click on the enter button. Here it will redirect it to this project title and some information about it, and then click on the sign up button. Here it will redirect to the sign up page containing of some information that are need to be filled to create an account. But my account is already created, that's why I'm using the sign in button. Here redirect to the sign in page containing of username and password that are need to be filled, and then click on the submit button. Here it will redirect it to this page containing of the choose file and upload buttons. Then click on the choose file button. It will redirect it to this page containing of various images within it. I'm selecting one image and then click on the open button and then click on the upload button. Here I predicted as of mountains, and then click on back button and the refresh button. By this we can upload the another image, and by this clicking on the choose file button and selecting one image and then click on open button and then click on upload button. Here it predicted as of aeroplane. And in conclusion, the Drone dataset facilitates the research of the object detection and tracking on the drone captured imagery. With over of 6,000 work hours, a vast collection of object instances are gathered, annotated and organized to drive the advancement of the object detection and the tracking algorithms. Meanwhile, several representative submitted detection and the tracking methods are reviewed, where the best submissions as of the 4 tracks are still for the real applications.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.